Hello everyone. So today we are going to work on an improved method to control the speed of AI driven car for this AI driving system. So this green car is using the new method and the red car is using the old method. So speed wise, green car seems clearly ahead compared to the red car that is utilizing the old AI driving method. So as you can see here, this is how much of an improvement that we would be able to achieve, but still you can see this has some shortcomings. For example, in this sharp curve it did overshoot the bend, but still it can manage pretty well because it has returned to the path correctly and it has now given a good lead to the old method. So yeah, this is what we are going to work on today. Now let's wait until it finish, until the green car finish the second lap. Okay, so as you can see, when we race, even though these AI cars can complete the round, take the turns and complete the race, they are pretty slow compared to the player character. So I want to improve the speed of the AI cars driving system. So for that, what I'm planning to do is I'm gonna drive the player car as fast as I can, and then I'm gonna record that data and use it as a reference for the AI cars to adjust their speed and so that it will allow them to go faster, so that they will have an idea like what's the maximum speed they can take in a certain area of the road. Okay, so but how can I do that? So first we need a way to record the speed of the player's car in each section of the road. That means in each section of along this spline. Okay, so for that, let me first open the Sport Car blueprint, and also here we need a reference to the road in order to record the speed. Wait, let me select the road spline, PP road, and here let's create a different mode to record the speeds. So I'll add a boolean variable record speed. This should be a public variable, and then also a reference to the car that we need to record the speed of. So another variable reference car. I think having an actor variable here should be enough, and I'll make this public. So now I'll add a function record speed. Oh, we can't have the same name because record speed is the variable name as well, so we need to have something different. Let's just say record. Now here let's get a reference to the reference car with velocity, and we can get vector length to calculate the speed. Now we need to find the location along the spline that this car is at the moment when this speed is when the car is going in this speed. So for that, I'll add another function, find closest point on road. So as an input, we need to give a location, and as output we need to give closest spline length, and that means along the spline at what length this given location is closest to a location on the spline. If you need me to elaborate that, let's say the spline starts from here. No, the spline starts from here. At this point, the length of the spline is 0, and here, this is the starting point. So at this point, the spline length is 0, and here it may be something like 2000. So if we give a location like this, we can find out what is the closest location along the spline to this point. So we can give that point on the spline as the length from beginning to that point. So that's basically what happens here. Okay, so here let me get a reference to the spline. Get location at distance along spline. Coordinate space, I'll use global, and I'll promote this to a local variable, distance. And then we can calculate the distance between this given vector and this location. So we can check if this distance is less than, we need another reference, another variable here, closest distance. No, not distance, let's say closest difference. This should be also a float, and here initially I'll have it have a very high value, so that whatever the first point we compare will be the closest point initially. So here, if this is true, we can't return yet. If that is true, this distance will be, we need another one, closest distance. The current distance will be the closest distance that represents the point closest to the given location along the spline. So distance will be closest distance, and the closest difference would be whatever this distance between the 2 points. And then we need to increment the distance, because we need to keep looking along the spline to find the closest distance. So this one, and let's add 500. Let's say. Oh, maybe 250. Right, and then oh, I forgot one more thing. Here initially we need to check if this distance that we are going to get the location along the spline is less than length of the spline, total length of the spline. Otherwise it would be a problem, because we can't get a location along the spline that does not exist. Alright, so after incrementing we need to wait. Circle back to the beginning, because we need to continue our calculation. Okay. When this becomes false, that means we have checked all along the spline. So we need to return closest spline length. This should be a float. And closest distance. That's what we need to return. Alright. Now we need to check if this is correct. And also find closest point on rod for the location of the car. Get vector location. And then let's have a map. By map I mean a map for a data structure. Can we have a map of two floats? Yeah. So speed at length. Sorry, speed at distance. So this will hold the optimum speed on the given distance along the road. Right, so we can add here. Oh, this also needs to be a float. Right, this is the distance and this is the speed. Now we need to check if we are getting the correct location along the spline. So to verify that, here I'll add the draw debug line. Starting point get location at distance along spline. So this location in the workspace, and the line end I'll add some offset 500 upward, so that's the end. thickness 10, duration 5 seconds. So we can confirm if this method is working. And we still haven't called this record function anywhere. So in the begin play, if record speed is true, let's start timer by function name. Let's call the record function with a timer, and maybe every 0.2 seconds, maybe not really, 0.5 seconds. Hope that would be enough. Okay, now check the road. We need to pick a reference car, so I need to use player. This is the player. So road, pick reference car, player as the reference car, and record speed. And we have made a mistake here. If this is false, we still need to continue without setting this. Oh, not return, reroute. Otherwise we will not get the closest point. Right, now let's see. Okay, this is the closest point, and yeah, it seems we are getting the correct point. So that's why we see this debug line closer to the car. Oh wait, I need to record the speed, and I need to go fast. So therefore, but I need a way to see the speed values as well. So therefore I'll make this public so that I can see the values, and also I might need to stop it if when I complete one round. But how do we detect one round? Right, we can get this value and see if it is nearly equal to the length of the spline. Oh wait, no, because I don't think I am starting from the very beginning of the road. The beginning is, where is it? Somewhere over here it has to be. Yeah. Okay, we can still make this work. Let me undo that. So get the length, and we can check if it is nearly equal with 500 tolerance. If this is true, we should create timer by function name, and function name is record. Now to make this work, we should start the player car in a point after the starting point of the spline. So here is the starting point. This is the starting point. So starting here should be fine. And I think I have set up a key to pause the game. Yeah, with num0. Okay, so select the road. This is enabled. Okay, we can see the speed and distance values as they are recording. Let me pause and select the road. Yeah, we already have 7 values. Okay, continue the report. '77, '79, '83. Are we going in a loop? Yes, we are. But yeah, this number should be enough. So we should have enough values now. 94. Okay, so we have recorded along the spline the speeds that the car had in each point. Okay, now once I stop playing, these values will be gone. So let me copy that and stop and paste. Cool. Now we have values. Right, now I'll remove the record speed button option, and initially speed is very low only because the car is starting from the starting idle, so from stationary, so not because it has to have that speed. So therefore I'll just fix it with 2000 or maybe even more, 2800. Okay, now let's go to the AI car blueprint. You already have it here, and we have a reference to the road as well. Right, now this AI speed, so this is 40. So this is the reference that we are using as the idle speed at all places along the track. So instead of that, from the road we can get speed at distance map. Oh wait, we would need another function here in the road. So get, let's just say get ideal speed. Spline distance. So this would represent the distance along the road that the car needs to get the speed. But does the AI car has that detail? Yeah, the car has this target spline distance. Okay, so it should we can use that. Okay, now spline distance, and from the speed at distance, the values here are in increasing order: 500, 750, 1000. So it should be easier for us to find the correct value. Spline distance. Oh, actually we are using, oh, we don't have a pattern here. Okay, so we can get the keys, and from these keys we can run for each loop, and we can get spline distance, which is same as this input, and calculate the difference by subtracting and getting the absolute value. So here I'll add a new local variable, min delta, and again here this should be a simple float, not a map. How to change it? Oh, I changed it to boolean. Okay, float. Alright, not an array, not a map. Okay, now as the default value, I'll again have a very high value. Then if this value is less than what we have for this minimum delta, delta simply means the difference. Oh wait, we can make this simpler. We do not have to go through all the elements actually. Yeah. Let me delete that. Let me just get the first element and calculate the absolute value of the difference, and then set min delta with that. Now let's have a follow with break. Should come here. Then again we need to calculate the difference between this and the spline distance. Also need to consider the absolute value, and if this is larger than the min delta, that means we are already in the, we have already found our closest position. If this is true. Oh, also we need another variable, closest spline distance. And okay, we need to set it initially with the first point. So that means this one. So if this is true, that means we have already found our closest point. So we can simply I don't feel safe to return like this. So let's first add the reroute node and break it. Or if this is false, that means, let me just make it quickly organized. So if this is false, that means this point is more closer than the point we already has the closest spline distance. So we will have to set min delta with this value and the closest spline distance with this value. Oh wait, no, with this value. Yeah, right. Now once this is completed, that means once this is either fully complete or break, we can return. What we need to return is this closest spline distance, and I'll make it a pure function so that we can call it without having to connect one of these execution lines. So here we are not considering this multiplication, so therefore we can just get this and check if it is less than, from the road, get ideal speed for the target spline distance. And that should go here. Now let's see what happens. I'm pretty sure this will not work in the first try, but they are going very fast. Oh, they are not applying brake. Let's see. Wait, we made a mistake. This is not what we need to return. What we need to return is, okay, what we need to return is the speed. So again, get the speed at distance and find, oh wait, yeah, find value for this closest spline distance, and that's the value we need to return. Now let's see. Yeah, now they have more control. See? Yeah, it's better. They are not as slow as before, and they even go over the road as well, but still they are fast, and they apply brakes and continue to go. Okay, why isn't this guy moving? Okay, they are moving. Yeah, they are working for me. Okay, nice. So what we tried is working. And I also made one more small change. Oh. it was still working even though there was an error. So here I made it +1 and -1. That's why the cars were braking drastically, like applying sudden brakes. But that actually works. Now previously it used to be like this. This way. Let's see again. Now to see in contrast, let me use the old value and simulate the game so that we can observe the difference in speed. They are more gentle and they are taking a more safe approach, as you can see here. So this is the old method. Cars are going correctly, but they are not speed enough, not fast enough. Now if I change it to the new method, now we should see the difference in speed. It's very fast compared to before. You see they are applying brakes everywhere to go faster and going, sometimes going away from the road also, but still they are maintaining their course. Okay, and now I'm trying to set up an experiment to see, to compare the both methods that I had for controlling the speed of the AI car. So for that, I'll here have a select and A will be here, B will be this, and I'll promote this to a variable. Use adaptive speed. So well, if I name it like that, then it has to be different. Then it needs to be changed. Adaptive speed means the new method. Okay, I'll make it public. And for this gray car, use adaptive speed. I'll leave it false. For the green car, I'll leave it true. Now let's observe what goes faster and how fast. Oh, the colors are randomizing. Let me quickly disable that. Here, this is where I change the colors. So I'll leave it disconnected for now, and then apply green here. Sorry, I thought I had paused recording. Alright, now the red guy is using old method, green guy is using adaptive speed. Now let's see who's the winner. Okay. Red guy is going very fast. Green guy is coming with more control. But yeah, it seems as for the speed, green guy is the winner. And here we have a problem, but still it can return to the road. So yeah, we have improved our system to go much faster. And thanks for watching. So as always, project files will be available for the download in the Patreon page. Link would be in the description below. And if you would like to support my work, you can get the membership of the Patreon Club. See you in another episode. Goodbye.